Okay, so we talked about systems of two variables. Then you watched the video about systems of three variables and saw what that looked like on a 3D graph. You also have a link to the GeoGebra, which is kind of cool, and you can kind of see what that intersection point is. It's very difficult to solve systems of three variables by graphing because our paper is not 3D, right? Our paper is 2D. So we would need to use technology in order to graph that, to solve by graphing. However, we can still solve algebraically through substitution and elimination. So here's our solution types for systems of three variables. Obviously, a system of three variables is a three-dimensional figure, a plane. So one solution is where all three planes intersect at one point. Thinking about like the corner of the ceiling. See, there's one point, kind of a dirty one point up there, but that's one solution. There's infinitely many when planes meet in a line or a plane. So kind of like right here, the corner of the room, that would be kind of like an infinitely many, although that's just two planes meeting. And then none would be parallel planes. So here's our first way to solve algebraically, solving through substitution. So this is going to mirror solving systems of two variables very closely. It'll just be a little bit more involved, obviously, because we're dealing with three variables, right? So automatically looking at our system of equations here, we have a couple of things that we can notice, right? When we solve by substitution, our ideal system, when we solve by substitution, is looking for something that only has, that we can solve very easily, right? So in this case, you know, I want to usually find something with just a coefficient of 1, but in this case, since I have one of my equations that only has two variables, I'm going to go ahead and use that one. So we're going to take this equation here, try to cover that the rest up so it doesn't distract us. So we have 3y minus 6z equals -6. And I can solve for either y or z. Just because my 3y is here and it's positive, I'm going to go ahead and solve for y. So I'm going to add 6 to each side. And now I have 3y equals 6z minus 6. And then I'll divide by 3. So that gets me an equation that's solved for y, solved for a variable, which equals 2z minus 2. So that means in either one of the other equations, wherever y is, I could substitute 2z minus 2. So I'm going to take my second one. There's no reason to do that. You can do the third one. I'd just like to go in order here. So I'm going to plug in 2z minus 2. Notice that it's x minus y, so it's x minus this 2z minus 2 plus 4z equals 10. I'm going to distribute out that negative, right? So I have x minus 2z plus 2 plus 4z equals 10. Combine my like terms. I have some z's here, negative 2z and a positive 4. I'm going to positive 2z. So I have an x plus 2z plus 2 equals 10. Subtract the 2 over, and I'm left with this x plus 2z equals 8. Okay, which is okay. We don't have another variable solved yet. So what I'm going to do is solve for x here because x has a coefficient of 1. So I'm going to solve for x by subtracting 2z. And so I have x equals 8 minus 2z. All right, now I have something solved for x. We had something solved for y, and we had something solved for x. I'm going to grab this value here, 8 minus 2z, and I'm going to plug it into plus 3z. Where did I plug it in? I'm going to plug it in. Trying to follow my train of thought here. Oh, here's my train of thought. Sorry about that. I'm going to grab my third equation and also use this 2z minus 2 to substitute. So we have 2x plus 2 times 2z minus 2 minus z equals 12. Distribute out that 2, put our like terms together, add 4 to both sides. So now we have two equations, right? I have an x equals 8 minus 2z, and I have a 2x plus 3z equals 16. That's good for us here because I can continue to substitute, grab the 8 minus 2z, plug it in for the x value here. See my arrows. So I have 2 times 8 minus 2z plus 3z equals 16. Distribute the 2 and then solve for z. So z equals 0. Once you have one solution, you can kind of go backwards. I'm going to go back to the x value, plug in the 0. I have x equals 8. Go back to the y value, plug in the 0, and y equals -2. So that going backwards is pretty quick once we've done the work at the front end. So our solution here is 8, -2, 0. So these three planes actually have one intersection point. It's that 8, 2, and 0. So let's try another one just together, and I'll work it out as we go so you can kind of see the process of solving through substitution. Let me find one of our examples here. Another one. All right, so let's take this example. This one's a little bit less complicated than the last one, and I will tell you, we probably won't use substitution very frequently in solving systems of 3 variables just because it gets very convoluted. And the Gaussian elimination method is more prevalent. So among mathematicians, right? Here we have x equals 10, 3x plus 2y equals 10, and x plus y plus 2z equals 0. Automatically we have a solution. This is really nice. That's one of our solutions. So we can just work down to plug these in. So I'm going to use 10 and plug it into this value here. Plus 2y equals 10. It's kind of a trickle effect. 30 plus 2y equals 10. Subtract 30. 2y equals -20 and divide by 2. And y equals -10. So there's our y value. Now we have two values, x and y. So we're going to use those to substitute for our third. So we have 10 plus -10 plus 2z equals 0. So let's see, we have 10 minus 10 plus 2z equals 0. Those cancel. We have 2z equals 0. And it looks like z equals 0 here. So our solution is 10, -10, and 0. So the way that we'll write that is x, y, z. Just like in your coordinate plane where you have x, y, this is how you write the 3D coordinate plane, x, y, z. All right, let's move on to our Gaussian elimination. This is one that we're going to use the most, solving through elimination. So here's our steps to solving through elimination. Remember in the system of 2 variables, we want same value, opposite sign, right? It's the same thing here. We're going to create equivalent systems by interchanging 2 equations, multiplying one equation by a constant, and adding equations together. So that's exactly what we do in the system of 2 variables. We just have to do it more. We just have to do it multiple times. So let's look at our system here. We have x minus 2y plus 2z equals 9. -x plus 3y equals -4, and 2x minus 5y plus z equals 10. So I'm going to start by grabbing 2 of these systems or 2 of these equations and trying to eliminate one of the variables. So if you notice right off here, we have an x and a -x. That's great. They are already same value, opposite sign. So I'm going to stack them and add them together since I don't have to do any work to get rid of anything. The x's cancel here. My y values add to get 1y, and my z values add to get 2z, and my constants over here add to get 5. All right, so what I'm left with is I'm left with a system of just 2 variables. Okay, that's good. Now I'm going to grab my first equation and my last equation. This equals 9 and equals 10. And I'm going to say, okay, well, none of the values match, right? But I can, if I'm eliminated x in my first go round, I need to eliminate x in my second go round. That way I have matching equations. So what I can notice is that if I multiply my x by -2, it would be same value, opposite sign. So that's what I'm going to do. And I got to multiply everything by that -2. So we have negative 2x plus 4y equals, or minus 4z equals negative 18. This one didn't change, so I just wrote it again. Look, my x values cancel. And here when I add, I have matching equations, meaning I have the same variables, right? I have a y and a z. So I'm going to grab those two variables, stick them down here, stack them, and then I need to make sure they have same value, opposite sign. These actually do, so my y's can cancel. I have a negative z equals negative 3 once I add my equations, divide by negative 1, and z equals 3. Now it's the process of moving back and substituting our solutions to find the rest of the solutions. So I'm going to grab the z. You can plug it into any equation, really, but I'm going to use, which one did I use? The top one, I don't know. You can use the bottom one, you should get the same answer. Y plus 2 times 3 equals 5. So y plus 6 equals 5. Subtract your 6 on both sides, and y equals negative 1. All right, so now we have two solutions. So we're going to go back to one of our first equations up here and substitute. So I think I used the very first one. I'm goofy like that. So we have x minus 2 times negative 1 plus 2 times 3 equals 9. Multiply those out. Combine your like terms, 2 and 6 to get 8. So x plus 8 equals 9. Subtract your 8 on both sides, and we have x equals 1. Now we have all three of our solutions, 1, negative 1, and 3. And so that is our solution set. That's where they intersect, those planes intersect. All right, we're going to work through another one together. So here's our other example, 2x plus 4y equals 6, 3x plus y plus 3z equals 17, negative 5x minus 8y plus z equals negative 10. All right, so my first step really is to look at my three equations and say, okay, do any of them have, do any two of them have same value opposite signs? X's, Y's, Z's. Nope, not really. So what we have to do is figure out, okay, which two are we going to get first, and we'll have to change a couple of them. So let's just do our first two, 2x plus 4y plus z equals 6, and 3x plus y plus 3z equals 17. So I want to, it's easier just to change one equation than to change both. I mean, it's just less work. We're all about less work. Let's go ahead and eliminate our z's here because I can multiply this by negative 3, and then it would eliminate with that 3 there. So once I multiply by negative 3, we get negative 6x minus 12y minus 3z equals negative 18. This one we're just going to copy down. 3x plus y plus 3z equals 17. Add them together. So when we add them together, our z's cancel, right? Negative 12 plus y is negative 11y. Negative 6 plus 3 is negative 3x. And we have a negative 1 over here. All right, so we have two variables, right? Okay, so we got to do this again and eliminate our z. So we started with the first and second one. Let's go ahead and do the second and third one. We could choose the first and second one too. Let's see. So we'll do 3x plus y plus 3z equals 17. Negative 5x minus 8y plus z equals negative 10. If we eliminated the z's in the first two equations, we have to eliminate the z's here too, or you wouldn't have x and y left, so you could continue. So we want to make sure to do that. So I'm going to multiply again by negative 3 here. Rewrite our first one. So we have 3x plus y plus 3z equals 17. This one, multiplying everything by that negative 3, we get negative positive 15x, positive 24y, and a negative 3z equals positive 30, right? Add our equations together. Z's cancel, that's great. We have an 18x plus 25y equals, what is that, 47? Ooh, getting kind of large. Numbers are getting kind of big. All right, so let's write these together because then we'll have to use our elimination again. So we have negative 3x minus 11y equals negative 1. We have 18x plus 25y equals 47. All right, so again, I want to see which one can easily be changed to the next one. Well, I could multiply this one by 6, and that would get me a negative 18. So I have negative 18. This is what, negative 66 y and negative 6. This one we're just going to rewrite 18x plus 25y equals 47. And here comes our math skills, our mental math skills. Our x's are going to cancel. Let's see, what is this? 1 and 4. Negative 41y equals, oh goody, positive 41. It's going to come out just pretty. Negative 41. So y equals negative 1. That's good for us. All right, so once we get our y, we're going to go back to the equation with two variables and plug in that y value. So negative 3x minus 11 times negative 1 equals negative 1. So we have negative 3x plus 11 equals negative 1. Subtract 11 on both sides. With negative 12 equals negative 3x. Divide by negative 3. And x equals positive 4. That's great. So now we need our third. So we're going to grab our two numbers that we know. I'm going to take the first one. So we have 2 times 4 plus 4 times negative 1 plus z equals 6. So we have 8 minus 4 plus z equals 6. 4 plus z equals 6. Subtract the 4 and z equals 2. So our solution set here, I don't have a whole lot of room, solution is 4, negative 1, and 2. That's our solution there. All right. Great job.